We are given the graph of the function f, and we're looking at the numbers at which f is not differentiable. Remember, differentiable means derivative exists. Okay, so this means derivative exists. And for derivative to exist, we need two conditions to hold. First, we want our function to be continuous at the given number. F is continuous at x equals to a. Second, we want the graph of the function to be smooth at x equals to a. So smooth graph is smooth. At x equals to a. If one of them fails, then our function will not be differentiable. Okay, so let's take a look at this graph. First of all, we see that the function is not continuous at -3. So since this first condition fails, f is not differentiable at x equals -3. So here f, actually that's a small f, right? F is not differentiable I will list several points. So f is not differentiable at -3. So x equals -3. We'd like to state our reason. F is not differentiable at -3 because it is not continuous. F is not continuous at x equals -3. We have a vertical asymptote here. Then we keep looking at our graph. Everything is nice and smooth up until -2. I see that my function have a discontinuity at -2. It's a jump discontinuity, but it's still discontinuous. That means the first condition fails. So f is not differentiable at x equals to 2. And same reason, f is not continuous at x equals -2. Okay, let's move on with the graph. Nice and smooth graph. Everything is nice and smooth up until I come to 1. I increase here and I immediately fall. So there is a problem here. We have a sharp corner, sharp edge in the graph of f. So f is not differentiable at 1 either. So x is equal to 1. Here our reason is different though. Our function is continuous at 1. So this holds, this first one holds. But the graph is not smooth at x equals to a. So f has a cusp at x equals 1, meaning we have a really sharp graph at 1. Right? Then we move on with our graph. Nice and smooth, it's almost flat here, then it keeps going down, and then here there's a hole in the graph. That means our function is not continuous at 3, so we have a problem with the derivative. Okay, so derivative does not exist at x equals to 3, and the reason for that is, again, the first condition fails. F is not continuous at 3. F is not continuous at x equals to 3. And these are the whole list. So we basically look at all the places where f is not continuous, -3, -2, +3. Those are bad points for derivative. Also, we look at the places where the graph is not smooth, where it has cusps like this or corners like this kind of corners. Okay, so that's all.